So my name is Eric Ernst, and I'm a member of the Dart team, and I'm located in Aarhus, and we're working on various tools, including the Dart2JS compiler. And you may have noticed that there is an issue about the size. So space frugal reflection is reflection where it doesn't take up so much space. So that's the reason why you might want to stay around to listen to this talk. If you've had this conflict, that you want to have dynamic code, for instance, if you want to invoke a method, you don't want to decide upfront at compile time exactly what the name of the method is. In that case, you need to use reflection. And if you do that and you're not careful, you will have a size explosion. So in particular, this happens in any platform where you're using a compiler that needs to do tree shaking, but it's commonly seen with Dart2JS. So it's a problem that's inherent. It's basically an issue that you don't know exactly what is going to be used reflectively, and this is an undecidable problem. So you can't really hope to remove the problem totally, but you can give programmers a better tool to tell the system what is going to be used. So we're writing this new package, Reflectable, and Reflectable will give you essentially the same interface as what you already know with Dart::mirrors. We have made some small updates because we think that's useful for the API as such. It's not because it's motivated technically by the implementation. So essentially the same interface, but you don't get this size explosion. So how does it work? Reflectable has a foundation, the basic idea, which is associated with metadata. So you have at something on the classes where you want to use reflection. So you declare reflection using metadata, and then you'll also specify which piece of metadata you want to use to get the reflection. So you can see it in the code here, that we want to use reflection with the class C. So we have created this myReflectable object, which contains a specification of a certain level of support for reflection. And then you'd use that to indicate that the class is included in support for reflection, and also to say that this is the place where we go to find the reflect operation to get a reflected version of this particular object, and that is a mirror. So this is just to show you, for once, this is the kind of code that you'll see. I'll go back to similar examples later on to explain how this works in more detail. So the idea was conceived by Florian Lorch. You already know him. You may have seen a public document that's called mirror tags, or it talks about mirror tags. Now we renamed it to Reflectable because nobody liked the word tag that kept turning up in the API different places. So now it's called Reflectable. That's far too long, so you're not going to put it in, unsuspecting places in your identifiers. And Reflectable is about where you can do reflection. Currently, I'm working on it. Sigurd has been helping me the past few weeks. So it's a project that's not particularly large, but we are making a lot of progress right now because we have sort of gotten the foundation in place, and we are now implementing the actual API. If you want to take a look at it, it's available at this location. It is able to run the examples that I show you today, but there's a lot of work to do on this still. So the basic concepts, I just want to give you the basic concepts such that we know that we're talking about the same things with the same words. So in particular, reflection as a concept has got to do with the ability of code to work on other code as data. So this makes it possible to create new program elements and to modify your program in arbitrary ways. So that's basically the old Lisp idea, where you would work on your program in a programmatic way. Now, if you restrict this to only introspection, so that means you can take a look at your program to investigate what are the classes around for this particular object, what is the class of this object, and for this particular class, what are the declarations. That's one part, and the other part is runtiming. That is taking something which is usually a static expression, like x.y, then the y is a compile time constant identifier. If you want to make the choice of which feature to use, which method to call or so, if you want to do that at runtime using a computed value, then that is what I call runtiming here. So these two things are the core of reflection. I guess this is totally well known, but I want to make sure that nobody would be in doubt of what it means. So here's standard code. I'm using Ruby code here to show you something that contains kind of an error that we don't have in Dart. Then I'll return to Dart code in the next slide. If you do something without reflection, that could be, we have a lottery class. We create a new instance of that lottery, and we have this convenient method called win. So we're going to win the lottery. If you want to do that in a way that's more flexible, then you would specify the class name as a runtime value, something you compute. It could be arbitrary computation involved. Here you have the win symbol. A symbol would be a string that is better with respect to its runtime performance. It could be canonicalized, it could be minified, there are various things, but basically it's a string. And then you could achieve the same thing as we had here. You create a new instance, but now it's not a compile time constant, it is a runtime expression. So we would get an instance of that class, and we do that by sending the new message to it. And then here we can do object.send, and that is a message that is a generic reflective message that will enable us to call a particular method, including that one. So this is reflection in the basic sense. The next step is that Gilad Braha and David Unger argued in an OOPSLA paper about 11 years ago that it's a bad idea to wrap up reflection together with the base objects. So the good design, there are lots of reasons for that in that paper, the good design is to separate them. So we want to have a separate system for providing reflection, and we do that using mirrors. So a mirror is an object that plays the role as a proxy that will allow you to perform reflective operations on the target object, on the reflectee of that particular mirror. So with that, you can have multiple mirror systems. That means that you can decide on what kind of mirror system you would have, and the traditional examples would be things like, oh, this is for runtime. Here's another one for investigating source code. Here's a third one for remote debugging for somebody else who's running on a different machine somewhere. In this case, we want to have multiple mirror systems because that will enable you to tailor them. If you want to have a lot of support for reflection with a few classes, and then there are lots of classes where you want to have more lightweight support, then you can tailor your system in a very detailed manner. So here we have Dart code doing a similar thing as what you just saw in Ruby. And the difference here is that you're not using a method on the object itself that says something like obj.send. Here we are working on the mirror to get the reflective operation. And other than that, it's just the same thing that you have already seen. So there's one concept here which is a kind of a detour, but it also illustrates the underlying issues. Why do programs get so large when you translate them with Dart to JS and you're not careful and you're using reflection? So the problem is that you need to preserve information about the program also at runtime. And minification shows very clearly why that will make a difference. So minification is known from JavaScript, and it's also a well-established concept elsewhere, but it's also known, it's also used in Dart with Dart to JS that we're doing this automatic renaming to take long names and transform them to the shortest possible names that are distinct, and we don't care about how readable they are. So we have these long names, and they disappear during the minification phase, and then we only have these short names. So my long readable name becomes xj7, and then if you look at the running program, it's actually going to do xj7, where you had this nicely named method. Now, if you have a class that implements no such method because you want to be able to handle the situation where somebody calls a method on this object that doesn't exist, then this guy is called, and then we can subject that invocation to a special treatment. So we take the invocation and we investigate, what were they trying to call? Oh, they were trying to call this foo37 method. So let's compute something, and that is an entirely dynamic thing here, the expression. And then we decide on whether that's what they're calling, so maybe we'll compute foo37, and then that's going to give rise to some behavior here, and then we can return the result here. And people will think, oh, this guy implements foo37. Now, that's used in a lot of places, and in this case here, you can see we have a new symbol and a runtime expression here, and we are comparing to the member name, which is a symbol, and that symbol has been minified. So now we have nice long name, and we're comparing to XJ7. So we can't answer whether they are equal to each other because we have to know the original readable version of that name in order to be able to determine whether it's the same name, because the programmer could never predict that this would become XJ7. That's just going to be this long readable name. So we have to preserve the mapping from all those short names to all those long names, or the other way around, or both ways, in order to be able to implement this. So this guy is expensive. And there is no limit to the set of symbols that you need to keep around in order to do this. So this is a good example why you don't want to use new symbol if you can use a const symbol instead. And it's also a good example of the kind of effect that makes programs so large. Okay, so what is the new approach that we're taking to Dart reflection using this new package? First, I just return to the existing reflection system. There's a very nice system for reflection that's called Dart::mirrors. It has a very compact representation at runtime at the JavaScript level, and you couldn't really expect to make it much more compact than that. But still, what we have seen in practice is that when people use this, they get these humongous programs, these large programs, and they're really not happy about the the space performance. And the problem is that it's hard to control what is supported by the reflective system using the available mechanism, which is this mirrors used adaptation. So what we're doing is basically we're trying to take an entirely different approach to this in order to make it possible for people to control the level of reflection in a much more detailed manner. Okay, so what we're doing with this new reflectable package is that we provide the same API. There are a couple of tiny differences where we wanted to make an experiment with the API. So for instance, if you call invoke in Dart::mirrors, you get a mirror. If you do this with reflectable, you get the actual object. Now the point is that you wouldn't want to create a lot of mirrors and then not use them for anything, because you're just looking up the reflectee and then dropping the mirror. So it seems to be okay to return the object directly, and it gives you better performance. And if you do want the mirror, then you can just recreate it by saying reflect to that particular object. So apart from tiny differences like that, it's the same API. That means you can just take your existing code that uses reflection and you adjust it in these tiny ways, and then it'll work. Manual process, but a very lightweight one. Then we have a transformer. That's basically a compiler that does whole program analysis and produces a program that does not use reflection anymore. So you have the pre-transform code. You can think of that as development code. And for the pre-transform code, you will use the library Reflectable, and Reflectable will indirectly use the library Dart::mirrors. So we're back to the old system, and it's going to take up a lot of space. But maybe you don't care at that point in time. And then you transform it, and the result is that we're generating static mirror classes, and they contain ordinary static code. There's no use of reflection at all. The whole system doesn't include Dart::mirrors. And at that point, we have this code that will actually do the same thing for you, but only for the cases that you have specified that you want support for. Okay, so what's this used for? Well, anything that you're doing that needs reflection, if you have a good case, then please come forward and tell us. And important cases inside Google is Polymer and Angular and serialization and Moustache, lots of cases. Anything that uses reflection. So the package itself, how does it look and how do you use it? You need to think in two steps here, because this is about mirror systems that you're tailoring for your particular purpose. So the first step is to design a mirror system that has the suitable level of support for reflection. And how do you do that? Well, we have this reflect capability class. You could say that this is a stupid class because it has no methods, it has no state. It's basically just the identity saying, here's a reflect capability subclass. It could be invoke instance members. It could be invoke static members, all kinds of capabilities. And then you just build expressions by piling up these things, building trees of these, and you could consider them basically as the abstract syntax tree for an expression. So what we have here is basically a DSL, a domain-specific language that will allow you to specify the level of reflection that you want to have. And then we tie that up with a particular object, which is an instance of the class Reflectable, and I'll show you how that happens. So here we have the core class Reflectable. That's in a library. That's in the library Reflectable, and you just include that. Then you create your own subclass, myReflectable, and you specify inside that class how much support you want to have for reflection. So here we have the Reflectable class. And one of the things it contains is the capabilities, which is a list of reflect capability. That wouldn't fit here. So you're giving an argument to this one argument constructor in order to specify what those capabilities are supposed to be. And you do that in a subclass that has 0 arguments. So we have a fixed setup here because that makes it easy to generate the code, because that basically means that for this particular class, there will be 1 instance. So we enforce this singleton property simply by saying it has to look like this. You have to have a constructor that has 0 arguments. This is just because it's easy to get started like that, and then we can generalize that later on, and we can support some more flexible schemes. But right now, that's the only thing you can do. You have to have a class that looks like this, and it has this singleton, single constructor that has 0 arguments and passes these arguments to the superclass. So that means that when we have this, we'll just continue, just move it over here and create a const, an object that is the single instance of that class. And now we'll use that the rest of the time. So when you look over your system and you decide that you want to have that level of support for reflection in this particular class, then you say add myReflectable on that class. And when you've done that in the suitable places in your system, then you have annotated where you want to have your reflection in a way that is local, it's bottom-up, and it's quite flexible. It's very easy to support generalizations of this, like if you choose to specify that myReflectable applies not just to the class, but to all the subclasses or to all the subtypes. It would be very easy to extend the capability language to cover that case. So we'll see what we need, but right now we're just going for the very simple approach where you put these guys everywhere you want to have reflection. Okay, so here again we have the myReflectable class, and we have this win method. And now we want to call this such that people can't see statically that we're calling the win method, because that's sort of unfair. So here we do that reflectively, and the only difference to what you've seen before is that we take the object and then we get a mirror for it, and we do that by asking the mirror system for its reflect operation, whereas the standard :mirror system would tell you to use the reflect operation at top level. So basically you can only get that specific version. And then you invoke methods using that mirror. So that's how it looks when you're using it. And here are a couple of words about the singletonness. So what happens is that if you have a subclass of Reflectable that has 0 arguments in its constructor, and it's just that single constructor, then we know how it's created. So if you have a const instance, because that instance has been canonicalized, so if you have 2 of them that have the same state, then you only have 1, because it's canonicalized into a single instance, and you just get more pointers to that one if you think you create more of those. That means that if we're editing the code of that guy, we'll edit the behavior. So if I edit, I think this is the slide that's best, this one, right. If we edit the code of this class, then we edit the behavior of that object. It's a one-to-one thing. So that's what we rely on currently, and we'll have to generate more classes and invent new fresh names and stuff. So it's going to be later if you want to have a more flexible approach to that. So here's an example of some actual running code. So this is just a prototype implementation of this win. Of course, if you do have an actual working implementation of that, we'd like to hear about that, and you can send that by private encrypted email. Otherwise, we just use this method here, and the structure of the whole program is as what you've seen until now. So what happens if we take this static program and make it reflective using dark mirrors and no special precautions? Well, it's just the extension that you've seen before. We get the same expression down here that you've seen several times. So let's just note that you can do this. If you want to be more careful, you can add this mirrors used annotation. So that's here. And in particular, one of the things you can say is that the targets are foo, and that means, oh, sorry, that's going to be lottery here. So the target is lottery, and that means that you're only going to use reflection on this particular lottery class. And that means that you can generate much more tight code. You don't have to have as much information about the program preserved as you would have if you're just using reflection in an unrestricted manner. If you want to use reflectable, you have to work a little bit harder because you have to specify the level of support. So the way we do that is by creating this subclass myReflectable of reflectable. It has this single argument constructor, it's zero argument constructor, and it passes this argument to the superclass, and it basically says, we want to invoke members, and that's all we want to do here. And then we have this const again. So what happens? Well, what happens is that if you're using the non-reflective code, it takes up like 9.6 kilobytes. If you're just using dark color mirrors, it's like 170 times bigger. So this is what people have seen. If you're very careful with mirrors used, you could get that down like 16 times to 100K. And if you use reflectable right now, you go to 78K. So basically, this shows that you have to be very careful about this, and we hope that we will give you a much more flexible path to specify the level of support for reflection that you want. And definitely, you wouldn't want to pay that unless it doesn't matter how much space programs take up. Okay, so the implementation. We have libraries, and we have a transformer, and the libraries work they work immediately. But if you want to have the benefits of this package, basically you need to run the transformer, and that's going to be an integrated part of pub build. That basically means that you will specify that you're using the reflectable and you're using that transformer, and then you're just running pub build, and then automatically your program is going to be transformed in the ways I described, such that it doesn't use dark color mirrors. For that, you'll have to use an import of reflectable, and you're not going to use dark color mirrors in other ways, because in that case, you're just undoing all the work that we have been doing here. So it supports invoke currently. Invoke getter and invoke setter are the new names for get field and set field. That's one of those little experiments we're doing with the API. They're going to be very easy, very similar. Code browsing requires a lot more code, so getting a class mirror, getting a method mirror, looking at all the declarations in the class, all those things haven't been written yet, so it's not ready. But if you want to fetch the code right now, you can at least play around with invoke and get an impression about how this works. So the basic idea here is that we want to create a balance between dynamism and output size. There is the core class reflectable. You would create subclasses of reflectable and pass in the super constructor invocation the value of type list of reflect capability that specifies how much support for reflection you want to get with this particular mirror system. And then when you design your mirror systems, you go around and apply them in your system, and it's going to look very much like dark color mirrors. But you need to remember to say myReflectable.reflect in order to get started, and basically that's it.